Module 11 will discuss new technologies with regards to rigid pavements. New technology is important to the designer because the department benefits by the reduction in life cycle costs, the introduction of new materials, and or methods of construction. These are important to achieve FDOT's goals of improving safety, inspiring innovation, and enhancing mobility. Construction projects that are experimental in nature may provide the department with valuable design and performance information. Experimental projects should be carefully coordinated with the State Materials Office Pavement Evaluation Section to set up controls and experimental limits so that the detailed performance evaluations can be made over time. Experimental projects should be limited in scope and not used for the first time on a major interstate project. This picture on the slide shows the State Materials Office in Gainesville and also their website to find any information and coordinate any experimental projects. New products are tested to determine their effectiveness under Florida conditions. Some examples may include components such as joint seals, concrete materials, additives, and curing compounds. You can find in the State Materials Office website some of the pavement research that has been done or is ongoing. Go under the Pavement Materials System and then select Pavement Research link, as shown here in the slide. Under the Pavement Research link, the pavement engineer can find information on the Accelerated Pavement Testing APT program. The site has current and planned experiments as well as completed experiments. The FDOT APT program is housed within the new State Materials and Research Park in Gainesville. The Pavement Systems Evaluation section directs and coordinates all activities associated with the APT program. A machine known as a Heavy Vehicle Simulator, HVS, as shown in this slide, is used in this program to subject pavement test tracks to accelerated loads simulating one half-axle truck loading. Generally, APT is defined as a controlled application of a realistic wheel loading to a pavement system simulating long-term in-service loading conditions. This allows for the monitoring of pavement systems, performance, and response to accelerated accumulation of damage. APT can produce early, reliable, and beneficial results while improving pavement technology and understanding prediction of pavement systems performance. So this website has some of that research, and if you would like to learn more about the research that it's being done or has already been done. Under the APT website, you can find completed projects, experimental reports for active projects in North and South Florida, and completed projects for North and South Florida. This is just one example of the types of completed projects, the evaluation of early strength requirements of concrete for slab replacement using APT. You can download any of the research studies under the website shown on the link below. Another experimental project that is ongoing is the FDOT concrete test road located on US 301. This is a 2.5 miles of experimental concrete pavement open to real-world traffic. The objectives for this project are to perform structural drainage and calibration experiments. It is unique that it is the only full-scale concrete pavement test facility of this type in the southeastern United States. Some of the structural experiments are to investigate different concrete thicknesses and base types from 6 to 10 inches with 5 different base configurations in use of reclaimed asphalt pavement wrap as an aggregate. Some of the drainage experiments include 16 test sections that will be constructed with and without edge drains. Concrete joints will be sealed and unsealed to study the effect of water infiltration. 2 concrete pavement thicknesses will be used while keeping the base type constant. For the calibration experiment will consist of 16 test sections to calibrate fatigue cracking equation within the Mechanistic Empirical Design Guide. In addition to these experiments listed above, several surface textures will be applied to evaluate effect on pavement friction surface drainage, and pavement tire and noise. Some of the proposed alternative surface textures include longitudinal grooving, a combination of longitudinal diamond grinding and transverse grooving in a new longitudinal grinding technique known as the Next Generation Concrete Surface, NGCS. Here's the website link to learn more about some of the concrete test road. These are some of the pictures from the placement of the concrete pavement for one of the experiments along Test Road US 301. As you can see, they install some indicators to monitor performance. Other new technology being used and designed for collecting data for concrete rehabilitation projects and for collecting pavement data for analysis or pavement forensics is using laser crack measurement systems, LCMS. The Materials Office has a multi-purpose survey vehicle, MPSV, with Pavemetrics LCMS-2. Each image represents 20 feet by 13 feet. These images are JPEGs resolutions. They can be up to 1 pixel, which is equal to 1 millimeter. They can provide faulting height calculations and can inventory each slab, which is essential for designers to use as a safe method for collecting this data and analyzing concrete rehabilitation projects. These are some additional images obtained using the LCMS technology. The images are downward images that use intensity, range, and 3D technology. As you can see, the pavement engineer can fully take measurements to determine the distress severity and prioritize the repairs or replacements of the slabs when doing a concrete rehab project. These are some of the LCMS images and report produced with GPS data, so the pavement engineer can import these images into the design file and keep good records of the analysis and crack inventory. The data can extract information capture per slab showing mileposts and with the GPS coordinates and categorized depending on the type of distresses. These are some additional images of the LCMS vehicle and cameras used to capture the distresses on the concrete pavement. On the right side of the slide, you can see the data collected from the vehicles to do the forensic analysis of the surface of the roads and bridges. The data output will have an image of forward view and then also a top view of the road. On the far right, a zoomed-in image of the top of the slab. In the data, you can have information by milepost, the length of the slab, the distress, and the severity. This is particularly useful to use in concrete rehabilitation projects and for capturing the faulting data in the slabs. FDOT has established a Florida Center for Pavement Excellence, FPCE. The mission is to address in a focused, timely, and cost-effective manner pavement-related issues. This group also is tasked to facilitate the rapid implementation of solutions and emerging technologies for the continuous improvement of pavement performance in Florida. You can find in this link provided in the slide the website and more information about the center's goal and contact information. This concludes Module 11. You're now ready to proceed to Module 12, Rigid Pavement Design Package.